watching this video. So in this video we're doing question 1 of May, June 2023, question paper mathematics paper 1. And these are equations, so solve for x. So we have 1.1.1, which is x squared minus 7x plus 12 is equal to 0. So they want you to solve for x. So you know, when you're here given something like this, straightforward. It's already in the form ax squared plus bx plus c is equal to 0. So when you're here, you can factorize it if it does have factors, or use the quadratic equation. So this guy does have factors. So we're going to factorize this or use quadratic equation if you can factorize. So you have x, you have 4, you have 3, it's minus minus. So x is equal to 4, x is equal to 3. These are the x values for this that satisfy this equation. So done with this one. So go to the next one. It's 1.1.2, right? So they wanted to solve for x here as well. So what did they give you? X into 3x plus 5 is equal to 1. So they gave you this equation here. They want you to solve for x here as well. So what do? First multiply this bracket out. So we have 3x squared plus 5x is equal to 1. So transpose the 1 to the left hand side. So 3x squared plus 5x minus 1 is equal to 0. Right? So when the form, so if you look at here, it's in this form: ax squared plus bx squared plus x squared plus bx plus c is equal to 0. So in here, you have quadratic equation or factorize if you can, or if it does have factors. So we're going to use our quadratic equation. What is our quadratic equation? Quadratic formula: x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is our quadratic formula, what we're going to use to solve this equation here. So we say x is equal to negative b. What is your b? Your b is 5 plus or minus the square root of 5, which is your b squared minus 4 times a. What is your a? Your a is 3 and your c is equal to minus 1 all over 2 times a. What is your a? Your a is 3. So you punch this on your calculator and see what you find. I'll do that just now. So negative 5 plus square root 5 squared minus 4 to a into c over 2 into a. So x is equal to negative 5 plus square root of 37 all over 6, which is x is equal to decimal form 0.18, right? And then go to the minus side, or x is equal to negative 5 minus square root of 37, right? All over 6. So x is equal to the decimal version negative 1.85. So these are your x values. These are the solution to this equation here. It's those two. Right? So we move. Go to 1.1.3. Still solving x. 1.1.3. So say given x squared is less than 2x plus 15. We're given this. They wanted to solve for x here as well. So what is negative 2x here? Transpose this to the left-hand side. Oh, right-hand side, sorry. So what do you have? You have x squared plus 2x minus 15 is less than 0, right? Once you have it in this form, ax squared plus bx plus c less or equal to 0, you find your critical values. So you must find your critical values when you have this form. So you say, okay, now x squared plus 2x minus 15 is equal to 0, right? So when you're here, you're exactly here. You're exactly here. So we find the factors of this, factorize this, or solve it using the quadratic formula. So I'm going to factorize it. Say, okay, it's equal to 0. X we have 3, right? And then we have 5 here. We have plus or minus. So we get that x is equal to 3, or x is equal to minus 5. So these are our critical values, right? At this point, our equation is exactly equal to 0. But we want it where it is below 0. That's where we want it. So plot a rough sketch of this parabola, which is this one here, so that we can see where it is less than 0. Say, okay, x, your y, your 3, and your minus 5. So it's a positive parabola, so it has the shape like this. Where is it less than 0? Less than 0 means below 0. At this point it is 0. At this point it is 0, right? It's below 0 here. This is where our function, our graph, is below 0. It's below 0 here. It's below the x-axis. This is our function x squared plus 2x minus 15. It's below 0 here. So it is less than 0 in this region. So what are the corresponding x values which are assigned to these y values? So the corresponding x values are these ones here. So which means your x should be in the interval. X should be in the interval minus 5 to 3. Or one would say x must be less than 3, greater than minus 5. Straightforward. Because you want it where this graph of yours below the x-axis here, right? So what are the corresponding x values? You read them on the x-axis. That's how this one goes. Easy. Then we go to 1.1.4. 1.1.4. I'm still solving x, right? So x minus 1. So given this situation here, so they want you to solve for x here. So first thing that we do, this part of the square root must always be isolated. So it is isolated, so it's on this side, right? The next step, what is it? Is to square both sides, right? This and that go away. You're left with 2 times 1 minus x is equal to x minus 1, x minus 1, right? Multiply the brackets out. So you have 2 minus 2x is equal to what? It is equal to x squared minus 2x plus 1. If you multiply this thing out. So transpose these to the other side. So 0 is equal to 0 is equal to what? X squared plus 2x, which is this one, minus 2x, which is that one, plus 1, which is that one, minus 2. So 0 is equal to this and that go away. We have x squared minus 1. Factorize this. So 0 is equal to x minus 1 and x plus 1, or you put it into a quadratic equation. Therefore, your x is equal to 1, or your x is equal to minus 1. So these are our solutions, right? So we want to check, we must check if both of these solutions satisfy the original thing that we're given. So we're originally given 2 into 1 minus x. We should always check these kind of things, x minus 1. So if x is equal to 1, right, what do we have? We have 2 into 1 minus x, which is 1, is equal to 1 minus 1. So this is 0, right? This will be 0, and this is 0. So these two are equal. So this is correct. Let's check the second one. We're checking for if x is equal to minus 1. So we want to check if these both sides will be equal. So what do you have? Say 2 into 1 minus x. What is your x? Is your minus 1. So we have plus 1 here. Is equal to minus 1 minus 1. Alright? So are these equal? That's what we're asking ourselves. Because we're asking the same question here, and then they turn out to be equal. So this is what? You have 2. So we have, if you patch this together, this is 2. Is it equal to minus 2? No, they're not equal. So these two are not equal. Therefore, this is not a correct solution. So the only solution is this one here. X is equal to 1. So we're done with 1.1. We're solving these equations here. So what I'm going to do, I'm going to clean the board, and then I'll go to 1.2 and 1.3. So let's clean the board. I'm writing 1.2 now. Solve for x and y simultaneously for the two equations given. So you're given these two equations. The first one is 3 raised x plus y is equal to 27. The second one is x squared plus y squared is equal to 17. They want you to solve this equation simultaneously. So what do? Say, okay, let me first simplify this thing here. So you have 3 raised x plus y is equal to 27, right? What is 27? 27 is 3 raised 3, right? So you have 3 raised x plus y is equal to 3 raised 3. So if you're saying 3 raised x plus y is equal to 3 raised 3, you are saying these two are identical, right? Which means this one is equal to this one, and this one should be equal to that one. So you want these two things to be identical. In order for these two things to be identical, the base should be the same, both of them, and the indexes should be the same, both of them. So which means if you want to achieve this, your x plus y should be equal to 3, right? So this is a similar version that you would like to work with. And then now, from this, you can say, okay, my x is equal to 3 minus y. This is what you can get salvaged from this equation. Solve your x there. Then you substitute this x on that complex one, on that equation of a circle centered at the center. X squared plus y squared is equal to 17. This is an equation of a circle that is centered at the center. So you have your x is that. So we see your x, you substitute that. So your x squared will have 3 minus y squared is equal plus y squared is equal to 17. Multiply this bracket out. So you have two of them. 3 minus y times 3 minus y. That's what the square means. Plus y squared is equal to 17. Okay, so now we multiply this bracket out. So we have 9 minus 6y plus y squared plus y squared, which is this one from this, and then this one is this one. It's equal to 17, right? Then you group the like terms. So we have 2y squared minus 6y plus 9 is equal to 17. Transpose the 17 to the right hand side, so you have 2y squared minus 6y plus 9 minus 17 is equal to 0. Therefore, 2y squared minus 6y minus 8 is equal to 0. So that's what you have. You can factorize this or plug it into your quadratic equation to find the values of y. So let's do 2 to what? Into y squared minus 3y minus 4 is equal to 0. So we have 2 into equal to 0. So you have y. We have 4, we have 1, we have minus, we have plus. So your y is equal to what? 4, or your y is equal to minus 1. Those are your y values. Since you have the y values, you must go and find the corresponding x values, right? So what do? You say, okay, x is equal to 3 minus y. So if your y is equal to 4, right? Then the x is equal to 3 minus 4, which is equal to minus 1. So you have the coordinates minus 1 and 4. If y is equal to minus 1, then x minus y, which is what is your y? It's minus 1 in this case. Sorry. Then x is equal to 3 minus y. What is your y? Your y is minus 1, which is equal to 4. Therefore, your coordinates are 4 and minus 1. We're done with this one. So those are your solutions, which is your solutions for those two equations, which is this equation and this equation. So yeah, done with this one. So where do we go next? We go to 1.3. So now we are doing 1.3. Determine, without using a calculator, the value of this thing here. They want us to find the value of this thing without using a calculator. Okay, so what is this thing? I don't know what it is. It is this thing. It is this series here. So what we can try to do is we can try to simplify each one of these things. This is the series, right? It looks like a series. So term number 1 is equal to what? Term number 1 is equal to 1 over root 1 plus root 2, right? So, you know, we can rationalize this, right? So when we rationalize it, we can say, okay, it's 1 over root 1 plus root 2 times root 1 minus root 2 over root 1 minus root 2. So this is 1 here. So what we're going to have, we'll have root 1 minus root 2, right? Over this times that, so we have 1. This times that minus root 2, right? This time that plus root 2 minus 2. So this and that go away. What are you left with? You are left with T1 is equal to root 1 minus root 2 over 1 minus 2. So to simplify this, we are left with 1 minus root 2 over minus 1. Therefore, the term number 1 is equal to minus 1 plus root 2. This is term number 1. So I'll say you do this for term 1, term 2, term 3, and your term 99 there. Right, let's do it. So this is our term number 1. So term number 2 would be equal to what? Is equal to 1 over root 2 plus root 3. So you rationalize it. So it's times root 2 minus root 3 over root 2 minus root 3. This becomes what? Root 2 minus root 3 over minus 1, right? Therefore, your T2 is equal to, what is it equal? It's equal to, I'll say it's equal to negative, positive 3 minus root 2. It doesn't look nice. So answer to that is root 3 minus root 2. Let's go to term number 3. What is term number 3? Term number 3 is this one. We rationalize this. So we have 1 over root 3 plus root 4. Right? That's what we have there. So we multiply it by root 3 minus root 4 over root 3 minus root 4. So this is 1. So you multiply it by 1. That's why they are the same. So this will be equal to root 3, right? Minus 2, really. This is 2 over over this, which is minus 1. This time this minus 1. Therefore, the term number 3 is equal to two minus root 3. So then we have rationalized this, and rationalize that. Let's go to this one here. So this one, this is term number 99, right? Because you see, term number 1, term number 2, term number 3. This is term number 99. So T99 is equal to 1 over square root of 99 plus square root of 100. Rationalize it times what? Times square root of 99 minus square root of 100 divided by square root of 99 minus square root of 100. This is 1. So your T99 is equal to what? Equal to square root of 99, right? Minus square root of 100 all over minus 1. So which is equal to negative or positive square root of 100 plus or minus square root of 99. That's what you're left with. So now, let's add the simplified divisions. So let's add our term 1, term 2, term 3, and term 99. So, and everything in between, of course. So term number 1 is this one, which is the same as that. Term number 2 is that one, here, which is the same as this one. Term number 3 is this one, which is the same as that. Term number 99 is this one, which is the same as that. So, if we add term 1 plus term 2 plus term 3 plus all other terms plus term 99, what do we get? We get that term number 1 was this. It was 1, negative 1 plus square root of 2, right? What is term number 2? Term number 2 was that which is negative square root of 2 plus square root of 3. What is term number 3? Term number 3 is this one. 2 minus square root of 3 plus all other terms in between plus our last term, which is term 99. Term number 99 is plus that, which is 100 minus square root 99. So it is obvious to me, at least, that if you look at this and that will go away, right? This and that will go away. So if you follow it, this will cancel whatever will come out here on the fourth term. And this continues, right? It continues. So the term that will be in front of this one here will cancel out what? The 99. So this one is cancelled by that, right? So this one is cancelled by this. This one is cancelled by this. This one will cancel by the next, right? So whatever term 98, it will cancel 99 and you'll be left with 100, right? So what you're left with, we'll be left with negative 91 plus the square root of 100. So this is minus 1 plus 10. So your answer to this looks like it's 9. So if you want to, you can say, okay, you're done with this, right? But if you want to verify, let's find the term in front of this one, term number 99, 98. Term number 98 will be equal to what? It will be equal to 1 over square root of 98 plus square root of 99. So if you rationalize this, it will come out as 98 minus square root of 99 over minus 1. So what will this become? It will become what? Square root of 99 minus square root of 98. So if you put this here in front of this guy here, so you have your square root of 98 plus or minus 99, right? So you can say this and that will go away. This will cancel whatever will be in front here. So I think that's how to do it. So yeah, thank you for watching.